Hi, everybody. This week's topic is axonometric and isometric drawings. So we're going to start with an overview of different drawing systems and then kind of focus into the Paraline drawings, including axonometric, and focus again towards the isometric drawings. I'll give you a step-by-step of how to do it, and then we'll move into a demonstration. Last week, you learned about different drawing systems and how they provide alternate ways to think about what you want to represent and how you envision your design. And so we learned about orthographic systems and multi-view drawings last week. This week, we're going to move on to some of the pictorial systems. So let's do some definitions of these different systems. Starting from the left here, orthographic projections, we learned last week, describe a three-dimensional subject or an object through a series of related two-dimensional views. And remember that no one view could fully describe the object. And so they looked kind of like this with the multi-view layout. All right. Moving to Paraline drawings. Para means parallel, by the way, they're parallel line drawings. In these kinds of drawings, you can convey your full 3D nature of your object in a single view in a pictorial format. The advantage of these particular drawings is that they are scalable or measurable, and they're also easy to understand. The third system here is perspective drawing systems, and they give a more experiential view. All right, and they'll depict an optical reality. And what we mean by that is that the perspective view is what our human eye sees. Perspective drawings are challenging to construct, but for the viewer, they are the easiest to understand. But this week we're studying Paraline drawings. They might also be called single view drawings, and that's to distinguish them from the multi-view drawings that we studied last week. There's a couple of different kinds of Paraline drawings, in two different categories. They can be axonometric projection or oblique projection. And then in axonometric, there's three different types. We'll look at all three of these: isometric, dimetric, and trimetric. And in oblique projection, you can have a plan oblique or an elevation oblique. So the most common of all of these in architectural drawings are the isometric, right here, which we're going to talk about today, and the plan oblique, which is next week's subject. So what are some characteristics of Paraline drawings? And remember, that includes all of the different categories we just talked about: axonometric and oblique. First, parallel lines on the object remain parallel in the drawing. They don't converge. In perspective drawings, they're going to converge to a vanishing point, but not in Paraline drawings, and that's shown right here. Right, see these parallel lines right here? They're not going to converge to a vanishing point. Second, measurements along your axial lines, X, Y, and Z, are scalable and measurable. All right, this is super important for ease of constructing these drawings and also for interpretation of the drawings. And so here's a demonstration right here, an illustration. The axes, maybe these are X, Y, and Z. These are the axes meeting at the origin point right here. And you can measure or scale along them to form a rectangular coordinate grid. And that grid will help you find any point in space. The third characteristic of Paraline drawings here are that they are always either aerial or worm's eye view. All All right, they're not going to be direct 90 degrees on like your orthographic drawings. And you're not going to have your eye at the horizon line like you do with perspective drawings. And so you are either looking from above, which is your typical view, all right, or you can also construct them so you're looking from below. There's a couple of different basic approaches to constructing your Paraline drawings. They're fairly easy to understand. The first is called subtractive. First, you draw a box, all right, an imaginary box, and then you cut or carve out material from that box to reveal the form that you're looking for. All right. You can think of this as your box is like a bar of soap, and you're cutting out excess material to reveal the statue or the shape or the object inside. The second approach is called additive, and you will draw a basic form, or they call it a parent form, and then add things onto it, subordinate forms. And so here's an illustration of that. In this case, the form is basically a box, and then it's got some extras added onto it. Right. The third basic approach is extrusion. You're going to begin either with a horizontal plane or a vertical section cut, and then extrude it in whichever direction is the opposite. All right, extrude the horizontal plane vertically, extrude the vertical section cut back into the depth of the drawing. The truth is that you need to know all three of these basic approaches, and you're probably going to use all of them in a complex drawing. All right, simple drawing, maybe you only do one or two, but you're going to combine these three to come up with your more complex drawings. The last thing I want to talk about in this video is visual depth in Paraline drawings. So you'll remember that visual depth is the illusion of distance or three-dimensionality on your two-dimensional flat surface drawing. All right, and we already learned two different ways, and actually several others, to illustrate visual depth or depict it. And one is line weight, and the other is shading. All right, and both of those are appropriate and work well for Paraline drawings. So you can see here on the right-hand side, we have an illustration of using line weight on this drawing. And so you can see that the spatial edge, it's called out, so that the important edges are darkened and maybe some less important lines are a lighter line weight. All right, and shading, here's one illustration of kind of a hatch pattern here, cross-hatching pattern, to add that illusion of depth. All right, a lot of the Paraline drawings, especially the isometric, it can get confusing about which item is in front. Okay, you can kind of get a little Escher-esque effects unless you use these visual depth cues. So in this video, we started out with an overview of some different drawing systems and focused in on Paraline drawing systems. In the next video, we're going to focus even further and talk about axonometric and isometric drawing. Thanks, everybody.